Okay, this is what you've all been waiting for. Chapter 4.7, Multiplied Decimals. We've been working up to this all chapter long. And I think you'll find it pretty easy. I'm hoping that this video will be a short one. Let's remember that, real quick, 1 times 0.1 is 0.1. 1 times anything is itself. So 1 times 1/10 is 1/10. 1/10 times 1/10. We learned in the last lesson, we did the little things where we had 1/10 in a column multiplied by 1/10 in a row, and there was one little hundredth that overlapped, and that was our answer to 1/10 times 1/10, 1/100th. So 1/10 times 1/10 is equal to 1/100th, and what we notice is that we're moving, when we multiply by something smaller than 1, we move that decimal one place to the left. So here the decimal place stayed in the same place when we multiplied by 1. It's here with one place after it, and it's here with one place after it. We multiply by 1/10, it gets smaller. When we multiply, each place value is like multiplying by 1/10 more or 1/10 less. It moves one place over. Okay, so you'll see that coming up here in our next pattern. 1/100th times 1/10. In this case, the answer is going to move over 2 places instead of just 1, and you get 1,000th. And what we need to see is kind of the long and the short of it is there are 3 place values here in the decimal side, 1, 2, 3, and our total decimal place value at the end is going to be that 1, 2, 3 also. Okay, so here we move the decimal from 1/10 over one place for the 100th. Here it's going to be moved over, if you look in the book, it's in the book, 2 places because we multiplied by 100th. So there's 2 places here, so we move it over 2 places, but our total is 3 places over. And that feels a little confusing, but it'll start to make more sense as we go along. First problem, it shows us 1.5 times 2.8. And it gives us a little story problem. A male leopard seal is measured and has a length of 2.8 meters. And a male is about 1.5 times as long, so we multiply these two numbers to get the length of the male elephant seal. Well, the important thing is that we're multiplying here, and we're going to use the pattern. We're going to do kind of what we did in one of the previous lessons where we set it up, and then we get rid of the decimal. So 2.8 times 1.5 looks like this, but we don't really want to multiply with these decimals, so we multiply by 10, the top and the bottom, so that we have 28 times 15. So this multiply by 10 we're going to undo a little later. Okay, we're going to go ahead and multiply. 5 times 8 is 40. It's supposed to look like a 4. 5 times 2 is 10, plus 4 is 14. In our second row we're going to hold the place value for our ones place, because now we're multiplying by tens. 1 times 8 and 1 times 2, and we add everything up, and we got to carry that one. 4 plus 8 is 12, and then we get 420. 2, 3, 4. 420 is our answer, and then we have to remember that since we multiplied by 10, we're going to unmultiply by multiplying by 1/10 both of these, and it puts our decimal places back. It gives us 1 plus 1 equals 2 decimal places. And so we're going to put 2 decimal places in our answer. We're going to start with 420, and we're going to put 2 decimal places in our answer so that the decimal actually goes here at 4.20. So the answer to 2.8 times 1.5 is 4.20. It's okay for us to solve it using 28 times 15. 28 times 15 is very similar to 2.8 times 1.5, but we get rid of the decimal by multiplying by 10 and then put the decimal back in. And once you've done this a few times, you don't even have to worry about this times 10 and times 1/10. You just, I forgot to put a multiplication sign in here, so there it is. You just do it without and then put the decimal in. You count your total number of decimals, 1, 2, and you make sure your answer has those decimals. Okay, we're going to do it just like that. And if you had more decimals, it would be similar. So that's really all the lesson. That's it. Let me show you just real quick one that's a little harder. This is from your lesson as well. It's not really harder, it just has more decimal places. Now here's one you can see the decimals don't line up. So you can't just, and a lot of times kids want to bring the decimal straight down. You can't put the decimal in the problem because they don't even line up. And there's no way to really make them line up. It doesn't work very well to go 6.98 times 2.50. It works okay, but then you have 3 places and you got to add the 0 in the second line, and then you have to have 2 zeros in the third line, and it gets complicated. So we just take the decimals out and we just go ahead and multiply 698 times 25. And we just go right through it. Okay, 8 times 5 is 40. 9 times 5 is 45, plus 4 is 49. 5 times 6 is 30, plus 4 is 34. Add a 0. 2 times 8 is 16. Carry that 1. 2 times 9 is 18, plus 1 is 19. Carry that 1. 2 times 6 is 12, plus 1 is 13. Then add it all up. It's 15, carry the 1, is 10 plus 4 is 14. Carry the 1. 3 plus 3 is 9, plus 10. You got to carry that 1 again. All right, so we've got all these numbers, 5,050, 50,050. Interesting. That is what we think the answer is, but we have to go back here. See, I put a comma in here, but our answer can't have a comma there because we have to count up our decimal places from our original problem. There's 1, 2, 3. And so if our answer has a 50050 in it, we need to come over 1, 2, 3 and put a decimal place in right here. So it's 50 and 50 thousandths. 50 and 50 thousandths is our answer. I don't like that answer. There's a reason I don't like that answer, because 6 times 2 is only 12. Even if I rounded 6 up to 7 and I rounded 2 up to 3, that would only be 21. So there's definitely something wrong with my math here. This is why you check. 50 doesn't make sense. If I did an estimate, 6 times 2, it's 12. So I did something wrong, and you might have seen what I did wrong, but we're going to go ahead and really quickly just do this again. And we'll do it in blue just to check our work. Okay. Okay, so the first section looks pretty good. And 6 times it would be 3,000, and this looks right. Okay, so the second section must be where I made my mistake. 16, 18, 19. I don't feel like I made a mistake. 12, 13. Somehow I got a 4 in there. Oh, my plus 1 ended up looking like a 4. Well, you probably saw that. You probably saw me do that. And you're calling me on the phone saying, Mr. Armstrong, stop making those mistakes. I do make mistakes sometimes. Sorry about that, kids. Everything else looks good. Everything up until the very end of the problem is still the same. Hold on a second. 0 plus 0 is 0. 9 plus 6 is 15. Carry the 1. Oh, I did that wrong up here too. Boy, I was just going too fast. Erase this one real quick. Oh, that doesn't work to erase. This one will. Okay. Kinda. Okay, so 9 plus 6 is 15. Carry the 1. 9 plus 1 is 10. Plus 4 is 14. 3 plus 3 is 9. Plus 1 is 10. And then 2. This is supposed to be a 4. 9 plus 14. Okay, yeah. 20,000. That makes a lot more sense. So if this rounded up to 7 and this rounded up to 3, that would be 7 times 3 is 21. And my answer is more like 20450. Count my 1, 2, 3 places. Put my decimal in is 20. 50 doesn't make any sense. 20 is reasonable, because 6.98 is almost 7 and 2.5 is sort of close to 3. 7 times 3 would be 21. So this works. Okay, you guys will just have to forgive me on this one. We did everything right all the way up to the end, But you could learn one thing from this, which is to check your work. And I checked my work and it didn't make sense, so I reworked the problem and I got a better answer. And this one's reasonable. Even if it's not right and I made a small mistake, this is still a reasonable answer. Okay, talk to you later.